Then we have our wonderful example here of how you can save a bit of money, especially in pre-series in body construction. By the way, it is still the case these days that adjustments are constantly being made in the pressing plant and the molds are being rebuilt, in other words, reworked, so that the tolerances always further adapt or approach how it is ultimately desired. With this system here, we can speed up the whole process a little by measuring the body, and then depending on how the tolerances are required and which value is demanded, it can be adjusted here using an electric motor. This is done in a single step. Depending on which value is required, which height, this matrix is moved up or down here. Then, in one operation, it is embossed, and at the same time, these two holes are punched. This could obviously already drastically shorten the time for the pre-series, which of course also saves costs, because replacing and reworking the mold in the press shop, that's a lot of money. Here we have our fully electric clinching tool equipped with a NEMAC motor that develops 60 kilonewtons. So we already have plenty of power reserves. You can easily connect two components, mainly two sheets, together. It also has the huge advantage, not both have to be weldable. So, because we don't weld, we obviously don't have any heat distortion in the component. The downside is, as with nut setting, which I will get to in a moment, unfortunately it's not quite as stable as welding. Then we have our nut punching machines here. Our nut separator is usually connected with this, always ensuring a constant supply of nuts, which are then transferred here to the punch via this small electric motor. It then moves down and punches the component and simultaneously press fits the nut with an undercut. Through the flow of material, it then press fits the nut with the component. Then we have here our so-called suspension strut hole punch. They are used in pretty much every plant of the Volkswagen Group. The suspension is pre-adjusted so that afterward the body, according to these specifications, these holes are punched. Which brings us back to the topic, functional surfaces or functional holes. This version develops or features 150 kilonewtons. We also have a larger version, which is even more widespread. It even develops 250 kilonewtons. This is our so-called multi-control. This trusty device is equipped for the four most diverse applications. In this case, there are still programs stored for both the clinch pliers and the nut punch behind you. You could get this one up and running within 2 minutes. Currently, we have another software running here for the next exhibit, which you can now see here on the right side, our so-called PFS 900. This is a fairly new development of ours. The advantage of our PFS units is also, normally the pliers could now open 75 degrees, and this would naturally also provide space upwards to remove the component vertically upwards. Due to the changed kinematics compared to the PFS 900, the PFS 2200 can develop a whole lot more power. Here, for example, we have our multi-power cylinder, our standard drive for our C-pressing units so far. We have these in various sizes. The range goes from 10 kilonewtons up to 60 kilonewtons. Here we also have a small exhibit for number stamping. The PFS units, or also EPFS units, can of course also be used for stamping. The possibilities are of course a bit higher there. There are even fully automatic embossing machines that can, for example, show which shift, or rather which day in which calendar week in which year, which shift and which part it exactly is, with a continuously automatically increasing 3-digit number, for example. So there are various possibilities.